I'm Ryan Boyle, and I'm excited to be presenting open source forensic threat hunting. Before I start, I'd like to thank Optiv for helping me through my first conference presentation and allowing me to share with everyone on day one of the Source Zero conference. Jumping to the agenda, I'm going to walk through the setup, configuration, and usage of judge, jury, executable. Afterwards, I will demo a few threat hunts before we close out the presentation. Judge, jury, executable, or as I like to abbreviate it, JJE, is an open source forensic threat hunting tool that we will be using to perform hunts. I feel this tool has great data points to filter and query against to help identify suspicious files. Judge, jury, executable can be used in tandem with your traditional forensic tools. And I want to note that JJE does not replace your full forensic suite, but is designed to supplement threat hunting functionality. Judge, jury, executable requires .NET Framework version 4.8 on a Windows computer. Administrator rights to perform direct disk access and parse the MFT. Write access to a database or file is needed to store the scan output. And then for the installation, I'm going to walk through a quick demo. Zoom in here. So to get the judge, jury, executable files, you go to the GitHub and download the code. I typically download the zip, which I have already done, and I've also already extracted it. With that, you drill into the binaries folder. You have a console or GUI version of the application. I'm going to demo the GUI and the release version of that GUI. And double click the executable. That gets you started. Done with the setup. Evidence acquisition involves kicking off a scan against the NTFS partition that we want to perform threat hunting against. There are a few configurations that you can set to customize what data is populated in the scan output. I'm going to walk through this in the GUI and touch on each one of the currently available configurations. So the very first option here is the scan path. This can be the root of a drive. It can also be a subfolder. For this, I actually want to scan something other than the C drive, which is my computer. I want to scan a forensic disk image that I have. So we'll go ahead and browse and select that. Click next. I'm using OSF mount here, but I've also used Arsenal Image Mounter. For OSF mount, you do want to mount the entire image as a virtual disk. And if you do so, the next screen, the defaults are fine. All right, so we just want to make sure we scan the drive that has size. That looks like it's the K drive. So we'll change this to K. Next, we have the search pattern. You can see here we're filtering to star.exe, star.dll, star.drv. You can just do star to say scan all files, or you can specify a filter such as .ps1. That's for the PowerShell hunt I'm going to be running after this. So we'll go ahead and proceed there. Calculate entropy. Entropy is the randomness of the bytes in the file. So that's an interesting data point to utilize for threat hunts. And then next we have Yara. For the PowerShell hunt I'm going to be running next, we will be using Yara rules. And we just hit add, and then we select the condition we want those rules to be run against the file. We can run it against every file, which would be always. We can run it against only PE files, files of a certain extension, files of a certain MIME type, and then a catch-all rule at the end. So I'm just going to select always, browse to go find my PowerShell Yara rules I'm going to be using. We just hit OK, and it puts them off to the side here. You can save these rules in a filter or load saved rules. Next, we have the output. So judge, jury, executable can output to a CSV file, a SQLite database, or a Microsoft SQL Server database. For the PowerShell hunt, I'm going to be doing a CSV file. Browse. I'm just going to put it here, call it ps_hunt, and hit scan. Judge, jury, executable starts parsing the MFT, reading in the files, doing Yara scans, all that good stuff. So that brings us to our first hunt, which is the PowerShell hunt. For the PowerShell hunt, as mentioned, I'm going to leverage some Yara rules that I wrote that were designed to assist with PowerShell hunting in judge, jury, executable. These rules mostly identify capabilities and attributes used in PowerShell scripts. Another thing to note is that judge, jury, executable takes advantage of the Win32 API when verify trust. That verifies authentic code for signed code such as DLLs, executables, drivers, and also PowerShell scripts. So that is something we can use to filter on or filter out as we're performing our hunts. Go back. And looks like the scan just finished. It took 9 seconds. And thus I should have, scroll out, a CSV file. I do. Let's go ahead and drill into that. When I'm hunting in Excel, I typically want to insert a table. It just makes things easier on me. So do that. The other thing I want to do is bring over the Yara column here. And I want to put it next to the file path. So that's how I'm going to sort first. I do want to filter out any file that didn't have a Yara match. And then I'm going to sort by the file path. With that, I'm going to look for any file paths that look abnormal, and then look at the Yara rules that are associated with that file and see if we can identify anything that's suspicious. Lots of what looks like built-in files. You can always, look at date stamps, get those in here as well, just to see, was there anything recently modified or written to the disk? So these files really stand out. These 3 here, 2 of them have the word backdoor in them. That doesn't look good. Let's look at the Yara rules for these. Let's actually zoom in so we can see a little bit better. So those are our file names. And here are our Yara rules. So we got attack tool sets. That means that this had a string in it that is common within an attack tool set. So not looking good that this is a benign file. It also does base 64, get bytes, network reconnaissance. It's got the string payload in it, redirects output, risky operations. Those are things that a lot of malicious scripts might do. So this is definitely looking bad. We also see invoke expression. That is really common to execute malicious code. On that note, what I wanted to show was you can do filters here. So if you know certain Yara rules that are really suspicious, you can go ahead and punch those in here, like the word invoke, filter to that, and filters down your results to the, did exclude one of the files, but we still have nc.ps1 and sketch tasks-backdoor.ps1. And so, I can drill into more files, look at more of these Yara rules, but I want to move on to the next hunt. So we'll zoom back out, close out of this hunt. Close out of here. And our next hunt is recently compiled executables. For this, we will be looking at the compile time within X hours of the MFT or NTFS creation times. We're going to use descending order to see the newest files on top. Files can be compiled on the computer, and there are many legitimate reasons why a file may have a compile time near the MFT or NTFS creation times. But it is a hunt that you can use to try to find outliers and suspicious files. So I'm going to demo that. One thing I wanted to note is this is just one way to hunt with compile times. You can also look for impossible compile times in the future or the past. Sometimes, again, that happens with benign files, but I've definitely seen it with malicious files as well. And we might look at that if we have time. For the compile time hunt, we're going to leverage Microsoft SQL Server Management Studio. So zoom in on this query I have here, and I'll explain it real quick. So we have the date add of plus or minus 10 hours of the MFT creation time, and we're comparing it against the compile time. Go ahead and execute this. Usually when I start a hunt, I want to see how many files I wound up with. So I got close to 5,000 files, which is a good amount of files to sort through. We don't really have time to walk through that. So we're going to try to narrow down on files that have some kind of trust issues. So it says here, we are excluding valid trusted signed binaries. So, obviously, the files in our results have some kind of trust issue with the signature, the certificate chain, and let's see what that narrows us down to. 3,000 files, 3,800. Okay, but look, right here at the top, we see something really suspicious. Looks like it's in a share, but it's named ssvchost.exe. It just looks odd. svchost.exe shouldn't be in a share. I can think of no reason why someone would name a file that, and it's not even named right. It's got an extra S on the front. So already suspicious file. The other thing I noticed on the screen is this file has a file owner of a particular user. You can see the SID here, but all these other files are administrators, NT authority system. We'll just scroll through these, see if we can find a user SID in any of these recent files. What's that? Administrators. Lots of NT authority system. Okay, here's some trusted installer. Yeah, but no user SID. So that makes it suspicious as well, just because it's not lining up with a lot of the other attributes of the files. Let's look at the compile time, see how far back we've gone. 2019, that's not recent. So we'll go back to the top. Let's look at some more attributes on this SVC host in the top row. See if we can find anything else weird about it. Obviously, it's not signed. Compile time is 417. Keep going, has no file properties. Yeah, definitely could be a malicious file. And we can see 417. 417, looks like something happened to it on 421. All right, well, this is a file we're going to look into further. Yeah, go through validation, maybe sandbox it. Let's go to the next hunt. DLL sideloading hunt. This is looking for DLL file sitting next to an executable file, which is actually pretty common on a Windows computer. Another thing I want to talk about is you could also do a variation of this hunt that's not necessarily looking specifically for DLL files, but it's looking for high entropy next to an executable file. This could get DLLs, executables, and other file types that may be suspicious. So we'll jump into that. It's over here. All right, show you the query real quick. So we're looking for an EXE sitting next to a DLL, and we're going to filter it some with, again, the file has some kind of trust issue. It's not properly signed. We're also going to exclude NT authority system and trusted installer for the sake of time. And let's execute it, see where we are. So 2700, not too bad. Scroll through these real quick. So battle.net, so video game, clam, ad blocker, free sieve, minicam, Silverlight, Visual Studio. So looks like a lot of really common files. One technique that I like to leverage to speed up a hunt is to include data from VirusTotal. So VirusTotal has great data points. I love to hunt with it. I can get, obviously, anti-malware security vendors, whether they detect the file, you get the compile time of the file, when it was first submitted to VirusTotal. There's just lots of good data points. I can't mention them all, but that's its own hunt. And so with this, I'm going to look and see what's not on VirusTotal to get the result set down. Execute this. What did we get it down to? Ooh, 261. So that got it down way more reasonable. Still have some Visual Studio in here. Well, let's go ahead and exclude that as well. Ooh, there we go. Look at that. We got how many files? 7. All right. So we saw this battle.net had a lot of files in it. Easy ad blocker. Java didn't really come up. We can definitely vet all of these files, just make sure they're not suspicious. But this Java one, just because it didn't show up in the query before, I'm gonna look at that a little bit closer, scrutinize it a little, see, can pivot off the imp hash there. Maybe see if that DLL file is using an import table that known malware has used. Compile time's pretty old on it. Interesting. Has no file properties, all blanks. And it looks like it was put on the computer not too long ago, 418. I scanned it in at 423. So not too long before we wanted to analyze this disk image. So you know what? When you're looking for DLL side loading, what you want to do is look at what's in that directory, because there should be an executable, obviously, based on our query. So let's just start a new query and see what is in that directory. So I'm going to type where. I see full path on the screen, so we're going to use that. We're going to do like, move the file name and put in a wildcard, close it out and hit execute. Okay, so not a lot of files in that directory. Let's see here. Oh, hey, look at this. svchost.bin. Kind of reminds us of the last hunt with the svchost.exe, except different name, same kind of hiding tactic, although to some of us that makes it stand out even more, right? Let's look at that file a little bit further. Let's scroll over. Looks like it could be interesting. Doesn't have an imp hash. It doesn't have a compile time because it has no MIME type. So it's a data file, I guess, some type. Keep going. It's not going to have any of this. Look at the entropy. 87 is pretty high. So this may contain some encrypted data or some compressed data. Let's see here. Yeah, and all of these seem to have a creation time on the MFT of 418, so they're all related to each other. When you see, an executable file sitting next to a DLL, and it's, I've never seen this res directory as part of Java. So you see it sitting in a weird directory, it definitely could be DLL side loading. So these you want to look into further. If you wanted to sandbox it, you're probably going to need all of the files in this directory. So you bundle those up, throw them in the sandbox, look at the behavior, static analysis, that kind of stuff. But before I close out this hunt, I wanted to show you the query I mentioned on entropy sitting next to an executable file. So close out of this. And here we go. So we're going to look for something that has an entropy greater than 85. And we're also combining it with it's not an executable file. We're doing that a couple different ways just to be safe. And then we're going to order by entropy. Don't want to highlight because SQL thinks I'm trying to run the highlighted stuff as the query, which is going to fail. And look, right here towards the top, we see the svc host.bin from our last query. So I want to show you this is because there's so many different ways you can think how to look for something suspicious on the disk and get as creative as you want. So we'll close out of this hunt and move to the next hunt. The masquerading file hunt will be looking for files that have the same name but have different metadata. We'll review those differences and try to find some suspicious files. So this query joins the table with itself so that it can compare the various files of the table and try to identify the differences. I learned how to do this by following the instructions in this Microsoft article. It explains that you go to query, design query in editor, and follow some steps to create a query such as this. You may want to rearrange the columns. You may also want to rename some of the columns because it gives you a whole new set of columns and it names them something like EXPR and a number. So you can rename those to something that means something to you. Application name compare. And that'll make it easier when you're reviewing the results. Also did a replace on the internal name to remove.dll from the results just to normalize things. I have the filter to show us any files that don't have the copyright, certificate subject, or product name matching. And then we're also looking at the file is signed but has some kind of trust issue. We'll run this. 696. So we'll scroll through these, see what we got. Windows side-by-side, .NET Framework, or .NET Framework, .NET Core, .NET Framework, Visual Studio. Looks like a bunch of noise we can filter out. So we'll get rid of .NET Framework, Visual Studio, Windows side-by-side, and run this again. Okay. So global assembly cache, framework and global assembly cache, OneDrive, LibreOffice, OneDrive again. Wait. So we got Bob has app data local Microsoft OneDrive, and Steve has app data local Microsoft OneDrive, but Bob also has app data roaming Microsoft OneDrive. Not sure why Bob would have two different versions of OneDrive, especially when Steve does not. So we'll see if we can find any other suspicious properties here. The certificate on these files looks weird. It ends at the root. None of the other files do that. Keep going. Okay, the copyright has an upside down question mark and a 1/2 symbol in it. Not sure why it would have that. Maybe a problem with converting the encoding, or I don't know. Looks weird. None of the other files have that. Keep going. Anything else? Okay. Looks like the internal name is OneDrive versus client application. Product name, Windows operating system versus Microsoft OneDrive. So we have some differences here. When we're looking at masquerading files, what we'll want to do is review all of the file properties. Right now, that query was only selecting some. So we'll filter to this file by putting in a where clause, bracket, file name equal to OneDrive, execute. Okay, we got 3 files. They have different hashes and similar size, owned by the user. Our one with the trust issue is 64-bit. The other two are 32-bit. Not sure if there's a 64-bit version of OneDrive. Something to look into, I guess. The compile times here are just way off. Impossible in the past and in the future, 1980, 1970, 2031. And then we have internal name and product name don't match. Version number, I guess this is just an older version. Our suspicious file is 20 versus version 21. Then the certificate issuer is different. This is code signing. This is not code signing. So that looks weird. And of course, this stuff doesn't match. Here's our certificate validity period. Looks like our suspicious file is valid after the other two, but it had a lower version number. So I would expect the opposite. Entropy is way off from these other two files. Then we have the creation time for these is 2020, but this one that's suspicious is 2021. Yeah, so it was modified the 17th, the other two, the 10th and the 21st. But I think we've discovered that this file has lots of weirdness going on. We're going to look into it further. Data exfiltration. Was there data exfil is a common question that comes up during incident response. There are many ways to look for data exfil, and what I'm going to demo is data exfil via an archive that is still live on the file system. Definitely want to look for this on the network, firewall logs, proxy logs, DLP, deleted files, that kind of stuff. Judge, jury, executable, where it shines is with active files on the file system. So we are going to look for files that have a really high entropy with this query. Zoom in here, show you the query. So pretty simple. We're just going to look for anything that has a greater than, so 99, 100, maybe 98 point something, that is ordered by the entropy descending. Okay. Let's look at the file names. Always like to start with those. Scroll over. And right away, we see something that doesn't look quite right. Second row here has a file in the recycle bin. It's in this particular user's SID. Usually, my understanding is recycle bin usually starts with a $ on the file name. This one just has a 1.7z. So 7z indicates it is likely a 7-zip compressed archive, which is kind of what we're looking for here. So let's look at the file size. Oh yeah, that's got a good amount of size to it. So this looks like it could be data exfil. Let's just take a quick peek at the entropy here, just to confirm all the way to the end. Okay, it is 100. So that's as high as it goes. Definitely either highly compressed or encrypted. All right. We'll definitely want to look into this 7-zip file further and see what other information we can gather about it. Just to be safe, let's look at what the recycle bin looks like just to confirm our understanding of that. Because this could be its own hunt, right? Just looking for something that doesn't begin with the $, but let's confirm. Yep. All of these have a $. Oh, some desktop.ini, but $. If you don't believe your eyes, you can just run the query. Just double check, triple check. Just make sure. Yep, just have that one outlier. So this could be a really good hunt to run on its own. And so as you're hunting, definitely look at things that look suspicious and consider that to be a future hunt that you're going to try out. That was my last hunt and concludes the presentation. Thanks for watching.